Hello, everyone. Welcome back to our channel Mechanical Universe, the place where we explore cutting edge technologies and sustainable solutions. Today, we have an exciting topic on our hands: solar thermal energy. Have you ever wondered how we can use the sun's heat to generate power? Well, you're in the right place. Before we dive in, don't forget to hit that subscribe button and ring the bell to stay updated on our latest content. Let's get started. Here are the contents of today's video. 1. Introduction. 2. How it works. 3. Types of solar thermal energy systems. 4. Advantages. 5. Applications. 6. Challenges and future scope. Solar thermal energy is a renewable energy technology that harnesses the sun's heat to generate electricity or provide heating for various applications. Unlike photovoltaic (PV) systems, which convert sunlight directly into electricity, solar thermal systems use the sun's heat to produce steam or other fluids that drive turbines or heat buildings. How it works. A solar thermal power plant operates by harnessing the sun's energy to generate electricity through the concentration of sunlight and the subsequent production of high-temperature heat. The most common type of solar thermal power plant is concentrated solar power (CSP). In a CSP system, large arrays of mirrors or lenses known as heliostats track the sun and focus sunlight onto a small target, typically a receiver located at the top of a central tower or along a linear trough. The concentrated sunlight heats a working fluid, often a synthetic oil or molten salt, circulating through the receiver. As the working fluid absorbs the intense heat, it reaches high temperatures. This heated fluid is then used to generate steam by transferring its thermal energy to a heat exchanger. The steam, in turn, drives a turbine connected to a generator, producing electricity. The key innovation in CSP lies in its ability to achieve extremely high temperatures, allowing for efficient and reliable electricity generation. Additionally, many CSP systems incorporate thermal storage, enabling the plant to store excess heat during periods of sunlight abundance. This stored heat can be later used to produce electricity when the sun is not shining, providing a degree of dispatchability to the power plant. Overall, solar thermal power plants showcase the synergy between concentrating solar technologies and traditional power generation mechanisms to deliver a reliable and sustainable source of electricity. Now, here we have types of solar thermal energy systems. 1. Flat plate collectors. 2. Evacuated tube collectors. 3. Parabolic trough collectors. 4. Solar power towers. 5. Parabolic dish collectors. 6. Concentrating linear Fresnel reflectors. Flat plate solar collectors. Flat plate collectors are the most common type of solar thermal system. They consist of a flat, rectangular box with a transparent cover, usually glass, and a dark-colored absorber plate. The absorber plate absorbs sunlight and converts it into heat, which is then transferred to a fluid, such as water or antifreeze, flowing through pipes attached to the plate. Flat plate collectors are commonly used for domestic water heating, space heating, and industrial process heat. Evacuated tube collectors. Evacuated tube collectors are composed of rows of transparent glass tubes containing an absorber tube. The air is removed from the space between the tubes to create a vacuum, which minimizes heat loss. The absorber tube absorbs sunlight and transfers the heat to a fluid flowing through it. Evacuated tube collectors are efficient in colder climates and are used for water heating and space heating. Parabolic trough collectors. Parabolic trough collectors use large, curved mirrors, parabolic troughs, to focus sunlight onto a receiver tube running along the focal line of the trough. The receiver tube contains a heat transfer fluid, such as oil, which is heated by the concentrated sunlight. Parabolic trough collectors are commonly employed in large-scale solar power plants for electricity generation. Solar power towers. Solar power towers use a field of mirrors, called heliostats, to focus sunlight onto a central receiver located on a tower. The receiver absorbs the concentrated solar energy and transfers it to a heat transfer fluid, such as molten salt or pressurized steam. Solar power towers are used for utility-scale electricity generation. Parabolic dish collectors. Parabolic dish collectors consist of a parabolic-shaped dish that focuses sunlight onto a small receiver at the focal point. The receiver typically contains a Stirling engine, which converts the heat into mechanical energy. Parabolic dish collectors can be used for both electricity generation and high-temperature industrial processes. Concentrating linear Fresnel reflectors. Concentrating linear Fresnel reflectors use long, flat mirrors to concentrate sunlight onto a linear receiver. The receiver contains a fluid that is heated by the concentrated sunlight. Concentrating linear Fresnel reflectors are used for electricity generation and industrial process heat. Now, here we have the advantages of solar thermal energy systems. Reduced reliance on fossil fuels. Solar thermal energy reduces the need for traditional fossil fuels like coal, oil, and natural gas, which are finite resources and contribute to air pollution and climate change. Cost savings in the long run. While the initial installation costs of solar thermal systems can be higher, they offer long-term cost savings by reducing or eliminating the need for conventional energy sources. Over time, the savings on energy bills can offset the initial investment. Lower greenhouse gas emissions. Solar thermal energy systems produce minimal greenhouse gas emissions compared to fossil fuel based energy sources, helping to mitigate climate change and reduce air pollution. Reliable and sustainable source of energy. Solar thermal energy is a reliable and sustainable source of energy, as it relies on the abundant and renewable power of the sun. It can provide consistent energy supply, especially in regions with ample sunlight. Now, here we have applications of solar thermal energy. Heating water for residential and commercial buildings. Solar thermal energy can be used to heat water for showers, faucets, and other domestic and commercial purposes. Generating electricity. Solar thermal power plants use concentrated solar energy to heat a fluid and produce steam, which drives a turbine to generate electricity. Industrial processes. Solar thermal energy can be used for industrial processes such as drying agricultural products or desalinating water. Now, let's come to challenges and future scope of solar thermal energy systems. High initial costs. One of the main challenges of solar thermal energy is the high initial costs associated with installing and setting up the necessary infrastructure. This includes the cost of solar collectors, storage systems, and other equipment. However, with advancements in technology and economies of scale, the costs are expected to decrease over time. Intermittency. Solar thermal energy relies on sunlight, which is not available 24/7. This intermittency poses a challenge as it limits the continuous generation of energy. However, advancements in energy storage technologies, such as thermal storage systems, can help address this limitation by storing excess energy for use during periods of low sunlight. Need for large land areas. Solar thermal power plants require large land areas to accommodate the solar collectors and other infrastructure. This can be a limitation in areas where land is limited or expensive. However, The development of more efficient solar collectors and concentrated solar power technologies can help reduce the land footprint of solar thermal power plants. Now, here we have the future of solar thermal energy. As technology advances and costs decrease, the future of solar thermal energy looks promising. Continued research and development, along with supportive policies and incentives, will play a crucial role in the widespread adoption of solar thermal energy. And there you have it, a glimpse into the world of solar thermal energy. It's incredible to see how we can turn sunlight into a powerful source of electricity. If you enjoyed this video, give it a thumbs up and let us know your thoughts in the comments below. Don't forget to share this video with your friends and family to spread the knowledge. Until next time, stay curious and stay green. Thank you for joining us on this solar journey. If you want more content on renewable energy and innovative technologies, stay tuned. And as always, subscribe for more exciting updates. See you in the next video.